Inshallah, today class we are going to continue the partial differentiations. Now you see on the board chain rule. How to solve the questions based on chain rule. Here the composite function, this z is called composite function. You see how we denote if z equals to f of u comma v, whereas u equals to suppose phi of x comma y and v equals to g of x comma y. If this is the given function, z equals to f of u comma v, where u equals to phi of x comma v, y, and v equals to g of x comma y. That means this u and v are related here with x and y. So if we want to find dou z by dou x, how to find this here? First we have to find dou z by dou u, dou z by dou u into, again here, dou u by dou x, dou z by dou u into dou u by dou x plus watch carefully. Now with respect to u, how we have completed, now we have to take with respect to v. So, dou z by dou v into dou v by dou x. So this is the chain rule. Once more you see, dou z by dou x equals to dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. In the same way, if you want to differentiate partially with respect to y, how we have to start? Dou z by dou u into dou u by dou x, sorry, dou y plus dou z by dou v into dou v by dou y. So this is called the chain rule. This is called the chain rule. And one more thing is we have to write the total differential coefficient. Just now see here, total differential coefficient. Suppose we are having z equals to f of x comma y, where x and y are the functions of t. X equals to phi of t, y equals to g of t. Then what is the formula? Watch carefully. Dou z by dou t. We have to find dou z by dou t equals to dou z by dou x into dou x by dou t plus dou z by dou y into dou y by dou t. Also, this can be written in short as dz equals to dou z by dou x into dx plus dou z by dou y into dy. This is called total differential coefficient. This is called total differential coefficient. So we do let we do a few practical questions on this. I request first to write all these two formulas and by heart this one. So let we do questions on this. Now see here what is given. Let I am writing here. U equals to f of x minus y comma y minus z comma z minus x. Now how to start means let we suppose let we suppose this thing. Let we suppose this by x r s t. We are supposing this by r, this by x, this by t. Now r equals to x minus y, no? X minus y by r, this by s, this by t. Now let we differentiate this with respect to x, y, z. Now what will be dou r by dou x? D by dx of x is 1, constant is 0. Dou r by dou y is 1, constant is 0. Now dou r by dou z, we don't have z here, so it will be 0. We don't have z here, so the constant differentiation is 0. In the same way, dou s by dou x, we don't have x here, 0. Dou s by dou y, with respect to y, 1. Dou s by dou z, with respect to z, here minus 1. Now in the same way here, dou t by dou x equals to minus 1. Dou t by dou y equals to, don't have y here, dou t by dou z equals to 1. Now see here, therefore what we are having, f y u equals to f of, these are r comma t, r comma s comma t. Now what we have to find, let first we find dou u by dou x. Watch carefully how to find dou u by dou x. With respect to x now, we have to write like this, dou u by, watch carefully, dou r, first with r, into dou r by dou x with respect to x now. Then go for s, dou u by dou s into dou s by dou x plus, now with respect to t, So what will be here? Dou u by dou t into dou t by dou x. Now let me substitute the values. Dou u by dou r into dou r by dou x is 1 here. Here its value is 1. Dou r by dou x is 1. So we substitute 1 here, plus dou u by dou s into dou s by dou x is 0, plus dou u by dou t into dou t by dou x is minus 1. So watch carefully. This will become 0. This is minus. So let me write like this. Dou u by dou r minus dou u by dou t. In the same way, let me suppose this is represented by 1. In the same way, let me differentiate with respect to y. Dou u by dou y. See here, first we have to take r. Dou u by dou r into dou r by dou y with respect to y. Then s. Dou u by dou s into dou s by dou y, plus now with respect to dou u by dou t into dou t by dou y. Now see here, dou u by dou r into dou r by dou y. Dou r by dou y is minus 1 here, plus dou u by dou s into dou s by dou t. Dou s by dou y, sorry, dou s by dou y is 1, and the last one is 0. Dou t by dou y is 0. Let me leave this one. So what is left here? Dou u by plus into minus minus, minus dou u by dou r plus dou u by dou s. Now lastly what we have to find? Dou u by dou z. Dou u by dou z equals to dou u by dou, first is r, into dou r by dou z. Dou r by dou z is 0 here, plus dou u by dou s into dou s by dou z is minus 1 here, plus dou u by dou t into dou t by dou z is 1 here. So you will get this as minus dou u by dou s plus minus dou u by dou s plus dou u by dou t. Now we have to add all this. Therefore dou u by dou x plus dou u by dou y plus dou u by dou z equals to the first one. What we got the answer here? Dou u by dou r. Dou u by dou r minus dou u by dou t. And this answers we got here, minus dou u by dou r plus dou u by dou s. This is minus dou u by dou s plus dou u by dou t. Now let me cancel this one, the last step. You see here, plus and minus will get cancelled. Plus dou u by dou r minus dou u by plus minus will get cancelled, and the answer we got is 0. Now see the next question. Z equals to f of x comma y, where x equals to e power 2u plus e power minus 2v, y equals to e power minus 2u plus e power 2v. We have to show that dou f by dou u minus dou f by dou v equals to 2 into x dou f by dou x minus y dou f by dou y. I wrote this one. What is given? X value and y value. Let me differentiate this with respect to u and v. See here, dou x by dou u, partial differentiation with respect to u. So d by dx of e power x is e power x e power 2u, but differentiation of 2u is 2. We don't have u here, it's 0. So come here, also differentiate with respect to y, v, sorry, dou x by dou v. We don't have v here, 0. D by dx of e power x is e power x. Now minus 2v differentiation is minus 2. In the same way, let me write here dou y by dou u with respect to u. D by dx of e power 2x is e power 2x, but minus 2 is minus 2 here. In the same way, dou u by dou y by dou v equals to, with respect to v, we don't have v here, 0. D by dx of e power x e power 2v, and 2v is 2. Now let me continue here. See here what to do. First let me find dou u by dou f, then dou u f by dou v, then we subtract this. First let me find this, then this, then afterwards we will subtract this. Okay, now see here, first let me find dou f by dou u. See here how to change. We have to change in x and then y like this. Dou f by dou x into dou x by dou u dou f by dou x into dou x by dou u. Now the same you write in terms of y, dou f by dou y plus dou y by dou u. Now what is this value? You write dou f by dou x as it is. Now dou x by dou u, dou x by dou u is, its value is 2, its value is 2 e power 2u. And sorry, into, no, here into, so dou f by dou y you write as it is dou f by dou y. Now dou y by dou u is minus 2 e power 2, e power minus 2, sorry, e power minus 2. So this is dou f by dou u. Now let me write, sorry, dou f by dou u. Now we have to find dou f by dou v. Now see here, dou f by dou v, dou f by dou v. First we have to change in x, dou f by dou x into dou x by dou v. Now with respect to y, dou f by dou y into dou y by dou v. See here, dou f by dou x you write as it is dou f by dou x, dou x by dou v, dou x by dou v is here minus 2 e power minus 2v. Now here plus dou f by dou y, dou f by dou y in dou f by dou y. Now dou y by dou v is 2 e power 2v, 2 e power 2v. Now we have to subtract this 2, this minus this. Therefore, dou f by dou u minus dou f by dou v equals to, its formula is 2 dou f by dou x e power 2u minus 2 dou f by dou y e power minus 2u. Now minus, no, here is minus, so you multiply this with minus. So minus into minus, this will become plus 2 dou f by dou x e power minus 2v, minus into plus minus 2 dou f by dou y e power 2v. Now let me solve this. Let me take common. See here, what we can take common from this 2? From this 2 we can take common 2 dou f by dou x. So what is left here? E power 2v 2u plus e power minus 2v. From this 2 you take minus also common, minus 2 dou f by dou y if you take common. Now what is left here? E power minus 2u plus e power 2u. Now the last step, you take 2 common from both, 2 into dou f by dou x, but this is given in the question as x, so this is x minus 2 dou f by dou y. This is given as y, so into y, sorry, you write this x before, it will be better, x into, and this y you write here y. So we got this dou, this value question is given as x, so I wrote x here, this value is y. 2 also we have taken common, now left with only y. So this is the answer. Now see the next question. Obtain the total derivative of z equals to tan inverse x by y. You see here, total derivative of z is written as dz. Its formula will be dou z by dou x into dx plus dou z by dou y into dy. Dz equals to dou z by dou x of dx plus dou z by dou y of dy. Now see here, dz equals to dou z by dou x means differentiation of z with respect to x. So d by dx of tan inverse x is 1 by 1 plus x square means x square by y square. You see here, d by dx of tan inverse x is 1 by 1 plus x square. Now we are differentiating partially with respect to x. So d by dx of, we have to differentiate this also. d by dx of x is 1, so this will be 1 by y. Again you see here, dou z by dou x means differentiation with respect to x. Tan inverse x is 1 by 1 plus x square. Now with respect to x means d by dx of x is 1 plus, no, sorry, this into dx. So this is dx plus dou z by dou y with respect to y again. So tan inverse x is 1 by 1 plus x square. But you see here, what is d by dx of 1 by x? This is minus 1 by x square. D by dx of 1 by x is minus 1 by x square. In that way, if we differentiate with respect to y, y is in the denominator, that is 1 by y. This differentiation is minus 1 by y square. So we can write minus x by y square into dy into dy. Now just let me take the LCM. If you take LCM, this y square into 1 y square will go into the numerator. To be like this, y square by y square into 1 y square. Let me write x square plus y square into 1 by y dx. So plus into minus, this is minus. Again, if you take LCM, this y square will come in the numerator, y square by x square plus y square. What is left here? Minus x by y square dy. Now let me take here common. See here, let me cancel this y square, cancel y square, y square. Sorry, we have already written here minus. Now let me take common. What can we take common here? In the denominator, we can take 1 by x square plus y square. We can take common. So what is left here? Y dx minus what is left here? X dy. So this is the thing we have to prove. Inshallah, we will continue in the next class. Inshallah, I request to the students to practice these questions and try few more questions of this type. Inshallah. So we are going to continue the next class to see the limits which are continuous or not continuous. Inshallah, we are continuing in the next class. Inshallah.